Welcome to qnawire.
So in this question, we have an electrical pole which has been knocked over by a storm. And we're going to assume this is level ground here and that we'll just say that the base of the pole is here. But instead of standing straight up and down, the pole has been knocked over so that it forms an angle of 104 degrees with the ground. And I'm going to just put a point up here and say that's the top of the pole. Now, the workers come out to check and try to fix things. And so we have an electrician sitting over here on the ground. We use E for electrician, 36 meters away from the base of the pole on this obtuse side. And the electrician, although they can't measure the pole directly, they can measure the angle of elevation from where they're standing to the top of the pole. And that angle of elevation there is 33.6 degrees. Okay, and what we're trying to find is the height of the pole. I'm just going to use X to represent the height of the pole here. So when we're solving a problem like this, it's really good to have a labeled diagram, labeled as much as we can. And we can actually now find this third angle up here in our diagram, because we know the angles of a triangle have to add to 180. So to find this angle, we can do 180 minus 104 minus 33.6 and find that that angle up there is 42.4 degrees. So this angle up here, try to write that in there, 42.4 degrees. So now we're going to be able to solve for X using the law of sines. We can use the law of sines when we know the measure of an angle and its opposite side, and then one other piece of information. So in this case, the side length 36 meters is opposite the angle 42.4 degrees. So I can say 36 divided by the sine of 42.4 is equal to, and then I can use the ratio of another angle and its opposite side. Well, the side X that we are looking for is across from the angle 33.6 degrees. So I can say that's equal to X over the sine of 33.6 degrees. So this is the law of sines, or sometimes we call this the sine rule. And now I'm going to be able to solve this equation for X. So if I want to get X by itself there, I'm going to multiply both sides of the equation by sine of 33.6. And we'll want to make sure that our calculator is set in degrees. And so this is going to give me sine of 33.6 degrees times 36 divided by the sine of 42.4 degrees. And when I enter that on my calculator, I get 29.5447. It goes on and on, but I can round that to the nearest hundredth. It's going to be 2 decimal places to approximately 29.54 meters. So the height of the pole is approximately 29.54 meters. And there you go.